Now, related to our center of gravity discussion is this thing called moment of inertia. In chapter 4, we called inertia really the inability to move. It's reluctance to move. It's resistance to motion. And that's where we're going to use inertia now, but inertia is more than just resistance to linear motion, it's resistance to rotational motion. But when we tend to rotate things, especially upon an axis within itself, it's sluggish to do that, dependent on not only its mass, but its size. So the moment of inertia not only has mass in it, it has the rotational size, the distance from this axis of rotation that we're talking about. So this is the definition of moment of inertia. And so this is a formula we're going to use for most objects, and particularly for objects that are rotating around an axis outside of itself. So if we're talking about the Earth going around the sun, then even though it is a big object and we'll have a different formula for the Earth spinning on its axis, this is the formula we're also going to use for anything going around something. Is if we're given point objects, we can figure out the individual sum of masses. And we do that by looking at it rotating. So we can just add things up. So I is equal to, I take the mass times the radius of this first guy. So each ball has a mass of 1 kilogram, so 1.0 kilogram. And it's on the axis of rotation, so it's 0 from the axis of rotation, so I get 0 squared, not that it matters, plus then 1.0 kilograms. And now we want to look at, so we're going to call this ball A, ball B. So this is A, B, and it's 0.1 meters from the axis of rotation. And then ball C is also 0.1, so 1 kilogram times 0.1 meters from the axis of rotation squared. So I get 0.01 plus 0.01 gives me a total moment of inertia of 0.02 kilogram meters squared. Okay, now are you ready to try this? So here we have a different system. This is 4 balls rotating about an axis, but basically we use the same formula. None of them are at the center, so I'm just going to say I is equal to 4. We're going to just add all these up of our 1 kilogram objects times 0.1 meters squared. And that gives us 4 times 0.01 or 0.04 kilogram meters squared.